This is just going to be a quick example about what happens if you're dealing with energy conservation for a rough surface. So let's say that this block has some velocity VA to start with, and it travels up this hill. This could be a very complicated geometry problem. So I'm not going to go too far into it, but how do you deal with the force of friction and the work as this block is traveling up the ramp? Okay, so force of gravity goes straight down. Force of friction goes this way. Normal force. And so these are the only forces that are acting on the block. So in this case, the force of friction, if we're talking about the work done by friction, is just the force of friction times the distance that the block is traveling. So the distance d here. But the force of friction is always going to be mu sub k times the normal force as the block is moving. But we need to figure out what that normal force is. And so if I look at this, the normal force will be equal to this side of my triangle. So this is theta. So the normal force adjacent side will be equal to mg cosine theta. So this will be the work done by friction. So if I am talking about the block as it's traveling up the ramp, I'll have all kinetic energy to start with at point A. And then the question is, like, how far does it go up the ramp before it stops? So the kinetic energy at A will be equal to the potential energy, the gravitational potential energy at B, plus the work done by friction, this value. And so you can see right now we have the height of the ramp, h, mgh here. We would need to use trig to find what h is or what d is in relation to each other. Okay, so I've redrawn my ramp here with my distance that the block will travel up the ramp and the height of the ramp. So the sine of theta will be the opposite over the hypotenuse. So I multiply both sides by d. So the height of the ramp will just be d sine theta. So I can plug that in right here. I cancel out my masses. 1/2 v squared equals g, gravitational field strength, times the distance that the block travels up the ramp, times the sine of theta, plus mu sub k, g, cosine theta times d. You can see there's a g times d in both of these terms. Now it's just simply solving for this d, the distance it travels up the ramp.